Hi, in this video, I'm going to discuss about convergence of sequence and what is a sequence and how to prove a sequence is not convergent, concept like that. Okay, so first we start with the definition of what is called a sequence. Okay, so a sequence is a function from natural number to R. You can have other sequences, but here we are discussing sequence of real number. That means that is a function from natural number to R. Let's give some example. Let's say xn is equal to n, where this notation xn means the nth term corresponds to n. Nth term is given by n. So what is can we plot it? If you plot it, you will see like this. Let's say for x1 will be 1, x2 will be 2, x3 will be 3, and so on. So this is corresponding to 1, this one corresponds to 2, this one corresponds to 3. Okay, so this one, okay, so x1 is here, x2 is here, 2, x3 is 3, x4 is 4, and x4 is 5, so on. So this is a sequence, and you can write the term like this, right? This is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term. Okay, so let's take another example. Let's say xn is equal to n square. So in this, you can write it, this is the sequence, right? 1, 4, 9, 16, 25, and so on. You can take another sequence, let's say 1, minus 1, 1, minus 1, 1, minus 1. And how do you denote it? You can denote it by minus 1 to the power n plus 1. This is correct, right? So these are sequences. Sequences are function from natural number to R. Okay, and now let's discuss what is called convergence. Okay, convergence of sequences. So motivation is something like this. Let's say we have a sequence, some, and let's say it attains a particular value. Let me just draw it like this. So these are the values. So when we go in x-axis to n tends to infinity, does it get closer to some value L? Then that value L is called the limit of that sequence. Okay, so these are the terms. Okay, your sequence may be something like this also. Let's say then you see this is something like this. So it does not it is oscillating, but it does not get closer to a certain value, right? Okay, and it can be like this, constantly increasing. Okay, so here also it is not getting closer to a particular value L. Whatever the value you take L, it crosses that and goes beyond that. Okay. uh, okay, so let's start with the definition. we say xn converges to L if for every epsilon greater than 0, there exists k belongs to, I will write n. N belongs to natural number such that if your n is greater than equal to n, then your xn minus L is less than epsilon. Okay. So this is the value. If you can find such L, then xn converges to L. If you cannot find any L, then this xn doesn't converge. Okay. So definition of xn is not convergent is if xn does not converge for any L belongs to R, then xn is said to be non-convergent. Okay. So okay. Sorry. Okay, let's give examples. Uh, let me choose some example. Uh, wait for a few seconds. Okay, so let's go with this one. 1 by n square plus 1. Okay. First, let's see the graph. Okay. So if you xn is equal to 1 by n square plus 1. So if you put 1, you will get x1 is equal to 1 by 2. Okay. So half. Okay. Here is 1, 2, 3, 4, 5 and half. Square, this is 1 plus 1 by 5. So this will be like here. And then x3 will be 1 by 3 square plus 1. That is 1 by 10. This is 0.1. So here. And then x4 will be even lower. That is 1 by 4 square plus 1. That is 1 by 17. So even lower. So you see, let me use some different color. So let's say these are the sequence. This is the sequence. So, so you see, this is the pattern it is following. So it is getting closer and closer to 0, right? This is 0. So it is getting closer and closer to 0 as n tends to infinity. So we will choose L to be, we can guess L to be 0. So what do we need to prove? Xn is 1 by n square plus 1 minus 0. This is 1 by n square plus 1. Okay. So this we have to show for every epsilon. We have to find a capital N belongs to 1 such that if n is greater than equal to n, then this thing is less than epsilon. Okay. So first see that n square plus 1 is greater than n square. Okay. So 1 by n square plus 1 is less than 1 by n square. Okay. Now, also n square is greater than equal to n, right? For all n greater than equal to 1. So this you can use. Okay. Now choose k to be greater than 1 by epsilon. Okay. Then if n is greater than, sorry, you take capital N. Okay. So now we have to show that if n is greater than equal to n, then this condition holds, right? If n is greater than capital N, we have to show 1 by n square plus 1 is less than epsilon. So what do we do? To use this inequality, okay? So since n is capital greater than capital N, 1 by n is less than 1 by capital N. And from this also you will get 1 by n is less than epsilon, right? So you can write it here, and also you use this fact. Okay. So this will give you 1 by n square plus 1 is less than epsilon. Okay. Now n is a positive natural number, right? It is positive. So you can write it as well as mod. Okay. So we have shown what is needed to be shown, right? This thing we have shown, right? So this part is done. Let's go to a different one. Okay. So this is CB. We'll find the limit of this sequence 3n plus 2 by n plus 1. Okay. Again, we will uh, find some value, and then you will see where it is going. Let's say put 1, then it will be 5 by 2, 2.5. So here, and now you draw the graph. Okay, I'm wasting time here. Okay, you will see something like this: 2.5, 2 point something, 2.6, 2.7, 2.8, and it will go closer and closer to this 3. Okay, this was 1, this is 2, this is 3. So as n tends to infinity, you can guess that it goes around 3. Okay, so I will take L to be 3, and then let's try to see what we can do. So you will get 3n plus 2 minus 3n minus 3, then n plus 1. Okay. So you will get 3 and 3 will cancel. This one will be minus 1 by n plus 1. Okay. So since mod is there, you can write 1 by n plus 1. Okay. Now you choose capital N to be greater than 1 by epsilon. Then again 1 by epsilon will be, sorry, 1 by n will be less than epsilon, right? And if you take n to be greater than this number, capital N, then 1 by n is less than equal to 1 by capital N, and also n plus 1 is greater than n. So 1 by n plus 1 is less than 1 by n. You use it here. So you will get 1 by n plus 1 is less than 1 by n, is less than 1 by n, capital N. And this one is less than epsilon from here. And so in total, you get 1 by n plus 1 is less than epsilon, and which is equal to 1 by n plus 1 modulus is less than epsilon. So your job is done. Okay. Uh, let's go do another example. Okay. Let's now do something which is where the sequence does not converge. Okay. So let's take the example xn is equal to. Okay. So this one is thing. You plot the graph. You'll see first value it will take is 1 minus 1. Okay. Then it will take 1, then minus 1, and 1, then minus 1, and so on. Okay. So, what do we do? We will use contradiction. Okay. So first we'll assume that it converts to a certain L, and then we'll show that it will lead us to something incorrect. Okay. So our assumption is false, and so it cannot converge to any L. Okay. So okay. So let us assume Xn converges to L. Then for every epsilon greater than 0, there is capital N belongs to natural, such that if N is greater than N, then Xn minus is less than epsilon. Okay. Now what I will do is epsilon is I will take it to be half. Okay, since this is true for every epsilon, I can take it half. Half is greater than 0, so it works. For that, you will get a natural number, capital N, right? So this capital N can be odd or even. Okay, odd or even. It can be any one of that. For any n greater than n, we have this condition that xn minus L is less than half. Okay, so let's see. I will do the case where n is odd. Okay, you can do the similar case when n is even. Both the case are similar. Okay, let's say n is odd. Okay, so first see that if you take n is equal to capital N, then this is equal to n, right? So for any n greater than or equal to n, this condition holds. So in particular for x capital N minus L, this is less than half also, right? Since n is odd, minus 1 to the power something odd minus L is less than half. Since this is odd, you will get minus 1 value, right? So it's fine with you, right? So you will get your 1 plus L is half. So you will get L is between 1 plus L is between minus half to half. Okay. Here I've used the property of modulus, and then I have opened up modulus. So it will be minus half to half. And then L is between minus 1. So this will be from minus half to minus 3 by 2. Okay. I hope I have not make any mistakes here. Okay. So keep that in mind. This is our equation 1. Now n plus 1, if n is odd, then n plus 1 is even. Again, if you choose n to be n plus 1, this is equal to greater than n, right? And in particular, for any n greater than equal to capital N, this condition is true. And n plus 1 is also greater than capital N. So we can use that one, x n plus 1 minus L. Sorry, you should write n plus 1 here. This is also true, right? Uh, so you will get minus 1 to the power n plus 1 minus L is less than half. So n plus 1 is even. So you will get 1, right? 1 minus L. And so you can write this L minus 1 is less than half mod. So this will be between 3 by 2 to minus half. Okay, so this would be half. Okay, so I made a mistake. Half. Okay. This follows from this. Okay, so this take it two. So what happens is, on one hand you demand that L is greater than half, and on the other side you say L is less than minus half. Uh, so that is impossible, right? So you know this gives us minus half is greater than half, which is absurd. So it's not possible. So we have arrived at a contradiction. So our initial assumption that xn converges to L is wrong. Okay, so xn doesn't converge to any L, and so xn is not convergent. Okay, this sequence is not convergent. And thank you for watching this video. And if you like this video, please consider subscribing and giving a thumbs up. I mean, like, thank you.